Hello everyone. Thank you for this opportunity for sharing this project. I'll get to it right away. We are a practice based in Delhi, and besides our own practice, we also do a lot of training in this area, in the area of sustainable building. This is one project in Panchkula for the electricity distribution company of Panchkula, which I'm going to be talking about. It's got recently completed, and the context is really as follows. I mean, so we live, we are all here in the NCR. So all of you know how the NCR is and how we've been living and suffering in this particular weather, climate, and in the whole gamut of carbon emissions, pollution, and so on. Now, on the other hand, on one side we have this kind of environment. On the other side we have, you've already seen, my esteemed colleagues have shown a large number of very interesting and green projects, and I'm going to show you one more. How do these individual buildings really make a difference to the overall city? And that's what we wonder about. Are these individual islands, or will they make a difference to the overall area? Now, in that, I think one of the most important initiatives has been the codes which have been developed in India and the push that the government of India has given to the development and to the mandatory usage of the codes. So the Energy Conservation Building Code originally came out in 2007, got revised in 2017, and is being revised again to further update the new developments in the profession. And in ECBC 2017, they had 3 levels to talk about the levels of efficiency that the building is touching. So one is ECBC, the second one is ECBC Plus, and the third is Super ECBC. So this is the first building, large-scale project, which has come out, which has touched the Super ECBC level. And after this, the government now has given each state 5 crores of rupees to upgrade or develop any project as an ECBC project, and they are quite bullish, so as to say, on this particular idea. The project here that I'm talking about was developed in Panchkula. Now, Panchkula is quite different from here. It's a much cleaner, place. You'd see the sun and, less pollution. But it does have an extreme summer and winter. So basically, this was the site. It's a 2 lakh square feet project. Basically, the orientation of the site itself is not really north-south. It is angled. So as you can see in the building itself, we created these 2 angles here to make it face north-south. Then if you see the diagram on the right-hand side, you will see the stepping is actually towards the eastern side. So that's an issue in all taller buildings or comparatively tall buildings. This is not really very tall. It's about G+6. But in that area, that is what is generally allowed. And in tall office buildings, people don't really have a space to go out to. And, sometimes you really don't want to go outside, especially in Delhi, you don't want to go outside. So here we created these terraces as go-to spaces on every floor. On the upper floors, you can also see a view of the mountains. This is Panchkula, so not very far away from the mountains. And, the diagrams below show you how the north-south works. That's a broad 3D picture, which gives you an idea about how the angles are working. And then we have the central entrance core, which is working as a circulation core that is naturally ventilated. The front green and the back green are kind of adding to the overall effect of natural ventilation going across that particular space. So the core itself is fairly compacted, as I will show in the plan itself. So that's the building where the stepping, I will say again, is facing towards the east side. So you can get good morning sun or even afternoon sun. Each of these terraces, because in the summers it does get quite hot, is having a metal frame over it, which is going to be covered with solar panels. Right now, they have installed part of the solar panels. The remaining is also going to be filled up with that. So the eastern terraces, as you saw going down below, those are still open, and the left ones are covered with solar panels, and they have all the services incorporated in the ceilings. All the cooling towers and other facilities basically are there. So that's a view again towards the taller side, where the left edge is basically the west elevation. So there are some classic orientational measures here. Being a north-south, the west is totally cut out, as you can see, minimum fenestrations, because that's a harsh sun coming from there. The south does have a reasonable sprinkling of windows to get adequate daylighting, but with an insulated envelope. And in the center, the orange jali is where the core is. So that's again the site plan where you can go all around. And that's the floor plan. Now in the floor plan, you also see on both sides, you do have these cutouts. Okay, I'll show you how they work. So these are the cutouts. So the idea being that, a lot of new buildings which are coming up don't have windows. And here we emphasized with the client that they should build open windows. Initially, they were very much interested in making these large areas which were glass facades which could not be opened. But this building construction happened during COVID. So at that time, their entire outlook changed because all the recommendations were targeting getting natural or fresh air basically into the building. So here, because of the open windows, we are able to get that. Secondly, together with the open windows and the cutouts, we are able to generate some passive cross ventilation in good weather times basically. The building itself is G+6 stories, and it has 3 basements below, as you can see. Within the building, of course, one has tried to keep an open office plan with possibilities of light being shared with the largest number of people. The partitions which are facing the openings are primarily glass, but the open office plan is basically low height partitions. So this was basically the analysis which was carried out by Haryana for it to reach the target of Super ECBC, where first the aspect of daylighting was seen, and the useful daylight illuminance factor was actually calculated on each floor, and in this particular case we reached the Super ECBC level. So this was a combination of artificial lighting and natural lighting together which did the job. And as you can see in this particular, in the picture on the left, even though you have a conference room, and normally you create a conference room where you cut out all the natural light, because you're creating your own interiors, you have a large screen which you want to light up, but the screens now are not projector screens anymore. So therefore, we were able to actually create a set of windows all around with roller blinds, where you can really cut out and get the thing in and get the roller blinds on when you don't want the natural light. So that's really the plan, and that's how it's receding on the eastern side. Further, 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 and there it goes. That's the last floor. So the building itself was highly insulated again as per Super ECBC standards. What we used over here was basically EPS core. It's a compact thermocol core, or high density thermocol core, as you can see over here, with these panels basically. They are 3 feet by 10 feet or 12 feet high panels, which get set up very, very quickly, and then you can shotcrete on them. So basically you get 8-inch thick wall section which is highly insulated. And we created it like that on the over the RCC, so that the RCC itself would also be protected. Otherwise, when you're trying to insulate a building, the RCC becomes a thermal bridge. So again, more ECBC values. I won't go into details, but basically from the baseline, we were reducing 47.4%, and then thus calculating the carbon savings as well. And these are, there was a high efficiency chiller, we had demand control ventilation over here, a BMS system, we had pre-cooling economizers to make sure that the incoming air is already pre-cooled by the outgoing air. We had operable windows, as I told, and because this was done during COVID times, so they were very much concerned about the infection control in the interiors. So this building, we also utilized UVGI systems where there was disinfection of the air which was actually going in and coming out. We also use filters, fine filters, to make sure that the kind of air quality maintained is impeccable. Talks about the concept. These were ECBC 2007 parameters. Like in air conditioning, you would cool almost 150 square feet with a ton. And now it's being surpassed, pretty much. The lighting power density, the electrical load, all these standards are being surpassed and new standards being made. So in this particular case, so the broad kind of last point which I want to make is that when we are talking about making a green building, you're talking about making a building better than the standard building out there. When you're talking about making a greener building, then you can also go to something like a net zero. This particular project which you were part of, this is called Indra Paryavaran Bhavan, building of the Ministry of Environment and Forest, which was a net zero project. This is another project for the RBI which we've been doing. Now, in these both projects, the ones on the left hand side, we primarily did part solar. So it was basically taking care of about 10% or 12% of the energy being consumed. But for the one on the right hand side, Indra Paryavaran Bhavan, this was taking care of the entire energy consumption. It was a net zero. So the net zero itself is not a very important concept, but beyond that, we have to look at how a project can target carbon neutrality. That is, in fact, balancing out the energy which goes into the making of the building. And that's where, going beyond net zero is important. And I'd like to take a minute in talking about one a particular concept which we are very much aware of and becomes the most important aspect of the building, which is the building envelope. So taking that as an example, in this particular building, the first one, we had basically this EPS core, yeah? So it had lesser embodied energy. Now in this particular case, the second building, we had a Fagi ball, which is basically a fly ash lime gypsum block, which is made with waste material, fly ash, which has the minimum embodied energy. Then the third one, basically, we had a high efficiency envelope with AC walls together with rock wool, which again has lesser embodied energy. But broadly, what I'm trying to say is that when you're taking the envelope, that takes up a major part of your embedded energy. And in that, you can do it in various ways. So for example, in this particular project, the Indra Paryavaran Bhavan, we did reach that same value of R with a AC wall. Now the same thing, if you don't have AC, could be done in a rural area by making a 1 feet mud wall, another 1 feet mud wall, and also a gap in the middle. You can do the same thing. Or in the city, you can do a half-inch brick wall and then you can have insulation in the center. So the same value can be reached in various ways, and it's a question of the context which is important. We have created this particular booklet which has been released under the aegis of the CPWD and the Ministry of Urban Development, where various materials of the schedule of rates have been utilized to see how the values that ECBC demands and which a green building demands can be reached comfortably. Based on this, we have carried out a large number of trainings as well. And this is my final slide. So what we have really in the built environment is really two kinds of buildings. You know, the one on the left and one on the right. So if you see the one on the left, this is a building example that I've taken from Auroville. And here, if we see the value on x-axis, that is the time span of the building. When we start, that is when the building has been constructed, and the blue line is basically the embedded energy of the building. So the embedded energy starts with a certain value which is above 2000 megajoules per meter square of the building, and it goes up slightly because you're also doing maintenance, maybe adding material, replacing material, carrying out repairs, etc. But the red line is basically the operational energy. Now this is a building which could represent, let's say, a local office, a primary health center, a school, having a small footprint, low embodied energy materials, some passive cooling, little or maybe no insulation, maybe a cavity, hardly any glass. So for these kind of buildings, basically, if we have renewable energy being utilized, then you can actually target carbon neutrality very fast, because the overall embedded energy itself is quite low. On the right hand side is the other kind of projects. It's like a Gurgaon building, office building, tall building, modern, air conditioned, with higher embodied energy materials. Now here we see that the embedded energy might be slightly higher. So this is touching almost 4000. Yeah, and again it gets maintained over the years. But look at the embedded energy. The embedded energy zooms up so fast. So it crosses the embedded energy in 2 years, and then it's zooming up. So that's where we do need high grade insulations, very high insulation to take care. So in this particular case, on the right hand side, I think joining the approaches of the embedded energy and the operational energy gives us amazing benefits in terms of mitigating carbon. Thank you so much. Thank you for your time.